Let's begin with a breath. Not just any breath, but the kind that melts tension from your shoulders and fills your chest with the subtle weight of evening. Maybe you're in bed, or perhaps still curled on the couch with the last light of day clinging to the window. Wherever you are, this story begins not in a rush, but in a hush, a slow fade like twilight softening into night. Outside, the world quiets. The bustle has settled. Streetlights flicker on like old stars rediscovering themselves. Trees barely rustle, their leaves shifting in sleepy rhythm. Far above, the sky stretches, ink black, speckled with light. The moon, that old sentinel, hangs steady and round, watching the planet it orbits with the patience of eons. Tonight we're going to talk about Earth, not just as a place, but as a cradle, a bubble, a sanctuary. And we'll wonder gently if it will always be so. Earth is our home, the only one we've ever known. Not just a planet, but our planet, with its rich blues, rolling greens, white ribbons of cloud, and a familiar gravity that tugs us down into sleep each night. For billions of years, it has nurtured life in a dazzling variety of forms, from simple cells to great forests, from trilobites to hummingbirds. And now it cradles us, humans with telescopes, languages, dreams, and questions. One of the quiet questions, the kind that lingers at the edge of philosophy and science, is this: will Earth always remain habitable, or will there come a time, far in the future, when this planet no longer supports life, not because it failed us, but because change is the only constant? To answer that, we'll need to take a long, slow journey through time, through the soil and sky, across oceans and into space. But before we begin, look around, even if just in your mind's eye. This is where we start, with the present. Right now, Earth is alive in every sense. Beneath your feet, the crust shifts imperceptibly, riding on molten currents far below. The ocean tides breathe in and out, pulled by the moon's steady hand. Seeds stir in soil, algae bloom in lakes, and somewhere in the deep forest, a fox pads silently over moss. This is habitability, not a switch, but a song, a harmony of temperature, chemistry, distance, and timing. Earth isn't just livable, it is just right. This balance, so perfect it seems effortless, is actually the result of uncountable coincidences and subtle systems interacting with quiet precision. But just as a lullaby eventually ends, we must ask, could this song stop? To explore that, we'll start by understanding what makes Earth habitable in the first place. Not just the obvious things like air and water, but the deep, interconnected networks of physics and life. We'll travel through ancient climates and far-flung futures. We'll listen to the slow language of geology, the whisper of winds, and the ticking clock of the sun's aging core, and we won't fear the answers. This isn't a story of doom. It's a meditation, a gentle walk through ideas. There's something comforting in knowing that nothing lasts forever, but everything leaves its mark. Now take another breath. The air you're inhaling was likely exhaled by someone else, somewhere else, days or weeks ago. It may carry molecules from a rainforest, a mountaintop, or the sea. This thin film of atmosphere, barely 100 kilometers thick, is the blanket we all share. It's held in place not by magic, but by gravity, the same gravity that allows rain to fall and oceans to stay. Sometimes, when we say the word Earth, we mean the dirt underfoot. But tonight, let's mean the whole thing, the soil, yes, but also the storms, the light, the orbit, the tilt of the axis, the moon that tugs our tides, and the magnetic field that shields us from cosmic fire. Imagine the planet as a sleeping animal, breathing, turning, dreaming in layers. Its rhythm's older than memory. It hasn't always looked like this. In fact, it's changed so much that if you traveled back 1 billion years, you might not even recognize it. Different air, different seas, different life, sometimes very little life at all, but still habitable. And somehow, that word, habitable, isn't a promise. It's a condition, one that depends on a fine choreography, the right amount of sunlight, a breathable atmosphere, liquid water, and a stable climate over time. Take away any of those, and life begins to falter. So we'll start here with the idea of habitability as a balance that Earth has kept for a breathtakingly long time, but not by standing still, rather by adapting, shifting, evolving. Like a tightrope walker moving slowly across a rope that itself sways in the wind, the sky above, the crust below, the spin of the planet, the chemistry of the air, all in motion, yet together they create something almost still, comfort, life. But how long can this last? Some things will change slowly. The sun, for instance, is growing brighter, not quickly, not in your lifetime, or your children's or theirs. But over hundreds of millions of years, this gradual brightening will warm Earth. It's part of the life cycle of stars. The warmth we cherish now will one day become too much. Other changes may happen faster. Our atmosphere, shaped by both natural processes and human hands, can shift. And when it does, it changes everything. Still, even with all these variables, Earth is resilient. It has endured ice ages and fiery epochs. It has gone from oxygenless skies to green forests, from barren coasts to coral reefs. It has healed from impacts, recovered from extinctions, and adapted to changes we can hardly comprehend. That is the wonder of it. Earth doesn't need to be static to be habitable. It simply needs to stay within certain bounds. But the question is, what happens when the boundaries shift? This is what we'll explore together, slowly without urgency, like a boat drifting down a wide, moonlit river. So tonight, wherever you are, city balcony, country porch, dorm room, hospital bed, or childhood bedroom, look up at the sky if you can, or close your eyes and picture it. The stars don't shout, they wait like old friends. The earth spins gently beneath them, and here we are, small creatures nestled in the crook of one spinning arm, wondering what tomorrow holds. But for now, tonight, Earth is still home, still gentle, still breathing. In the hush of night, when most of the world sleeps, the air feels closer, as if the planet leans in a little more to whisper something ancient. The sky darkens not into emptiness, but into a kind of protective veil, a dome of invisible threads that hold warmth close and danger at bay. This veil, our atmosphere, is the beginning of the answer to what makes Earth habitable. It is not just air, it is balance. It is insulation, filtration, pressure, and breath. Without it, we would not simply struggle, we would not be. And like all delicate things, it is easy to forget how fragile it really is. The atmosphere wraps around the planet like a soft skin. It is held not by barriers, but by gravity. Nothing walls it in. It does not cling out of duty, but because it is gently tethered to Earth's mass. It is a mix of gases, mostly nitrogen, enough oxygen to support animals, just the right sliver of carbon dioxide to keep us warm without overheating. Not too much, not too little. like a recipe passed down through time. One tweak too far in any direction, and the result collapses. Life, in all its richness, depends on this invisible mixture being just right. Take, for instance, the thin line you can sometimes see from space, the one that curves around the planet's edge like a blue halo. That line is the atmosphere, all of it. From the ground you stand on to the uppermost breath of air that brushes against the edge of space, it's barely 100 kilometers deep. If Earth were a classroom globe, the atmosphere would be thinner than a coat of lacquer. Yet in that thin layer exists all the air we have ever breathed. Every bird that has flown, every storm that has rumbled, every sigh, every breeze, every whispered lullaby, they've all happened within that delicate film. But it is not only the air itself, it is how the atmosphere traps heat from the sun. This process, called the greenhouse effect, is not a flaw, it is a gift. Without it, Earth would be a frozen world, its surface locked in ice. But with just the right amount of greenhouse gases, carbon dioxide, methane, water vapor, our world stays warm enough for oceans, for clouds, for life. It is the planet's slow, constant exhale that keeps the balance. Too much of these gases, and the planet overheats. Too little, and it freezes. This dance of energy in and out is what keeps the temperature stable. Stable enough for rivers to flow, for crops to grow, for children to play outside without protective suits. Now imagine that balance as a swing hanging in the breeze. Sometimes it sways forward, sometimes backward. Climate, after all, is not a single number, but a wide rhythm. Ice ages come and go. Warm periods melt glaciers. But the swing always returns to the middle until something nudges it too far. And that's where the fragility comes in. We often think of Earth as indestructible, and in many ways it is. The rocks will remain long after we are gone. But habitability, that's different. It isn't just about a planet existing. It's about it existing in a way that allows us and all the life we know to continue. That is a far narrower target. If you were to chart it, the range would be a slim band of temperature, pressure, and composition. Outside that band, things don't just get uncomfortable, they become impossible. This brings us to something quiet, but powerful, Earth's position in space. We orbit the sun at just the right distance, not so close that oceans boil, not so far that they freeze. This region is known as the Goldilocks zone, and Earth rests comfortably within it, bathing in sunlight that arrives just warm enough to sustain liquid water, but not so intense as to strip the atmosphere away. It's not just the distance either. It's the kind of star we orbit. Our sun is stable, long-lived, not prone to wild bursts or violent flickers. It is, by stellar standards, a calm and generous companion. Tilt also matters. Earth leans slightly on its axis, about 23.5 degrees. That tilt is what gives us seasons, keeps temperatures fluctuating just enough to encourage variety without chaos. Without the tilt, regions might bake endlessly or freeze eternally. And the moon, yes, even the moon, plays a quiet role. Its gravity helps stabilize that tilt, preventing Earth from wobbling too much over time. Without the moon's gentle pull, the axis could shift wildly, bringing dramatic changes in climate that would leave little time for life to adapt. Then there's the magnetic field, the unseen shield generated by Earth's spinning iron core. It deflects solar wind, a stream of charged particles that would otherwise strip away the atmosphere molecule by molecule. This magnetic embrace protects not only our air but also our DNA, shielding us from radiation that could unravel the threads of life. You can see it at work in the auroras, those green and purple curtains that ripple across polar skies. They're beautiful, yes, but also signs that our planet is defending us in ways we rarely notice. All of this, the air, the heat, the orbit, the spin, the shield, works in concert. It is as if Earth is a symphony and life is the music it plays. Every part must remain in tune, or the melody falters. It's not enough to have a planet in the right place. It must also hold itself together through subtle balances and ancient forces, many of which are invisible to the eye. And this brings us gently to a truth that stirs beneath the surface of our question. Earth is habitable, not because it was designed to be, but because it became so over time through a convergence of rare conditions. Life emerged not as a certainty, but as a fortunate result. And that means, perhaps uncomfortably, that it is not guaranteed to last. If things came together to make it possible, they could just as easily drift apart, but not all at once, not like a switch turning off. No, if Earth becomes uninhabitable, it will likely be through a slow fading, a soft unraveling, a shift in atmosphere, a warming sun, a changing orbit, a transformation, not of the planet itself, but of its song, a change in key, a soft discord. For now, though, the music still plays, the air still holds, the swing still rocks gently between seasons. And as you lie there, listening to the world breathe, you are nestled in one of the rarest, most fortunate bubbles the universe has ever known. A place not too hot, not too cold, not too chaotic. A home. Outside your window, the stars shine on, indifferent and ancient. They do not know us, nor do they care. But this planet, this fragile, perfect sphere, you know it, and it knows you. You are made of its atoms, born of its waters, warmed by its sun. And for now, you are held safely within its care. As the night deepens and your thoughts grow quieter, let us rise gently now, not into dreams, not into space, but just into the air above your home. Breathe softly and let your mind drift upward, through the ceiling, past the rooftops, through the cool hush of night wind and invisible currents that dance above the trees. Keep going, higher still, into a realm where the sky turns thin and blue begins to fade into darkness. You're rising into the atmosphere now, the great ocean of air that surrounds every moment of your life without once asking for thanks. We so often treat air as nothing, as space, as emptiness. But it is, in truth, a substance, a texture. It presses on you from all sides with a soft, steady hand. Every breath is filtered, mixed, and delivered by an orchestra of molecules so familiar we forget they're even there. But here, above the bustle of the world, looking down through these layers of invisible safety, it becomes clear. This atmosphere is not just a sky. It is a shield, a habitat, a silent guardian. Long before it became the gentle blend we breathe today, Earth's atmosphere was wild and unkind. In its youth, it was thick with volcanic gases, methane, ammonia, sulfur compounds, no oxygen, no ozone, no breath for lungs. It was the exhalation of a molten world, newborn and angry. Lightning cracked over poisonous seas. The air shimmered with unfiltered solar radiation. In those early days, Earth would not have welcomed you. It would not have recognized you. But something happened. Slowly, gradually, life began. And not the kind of life that walks or talks or wonders. Simple things, tiny cells, microbes floating in the oceans. They began to do something miraculous: photosynthesis. They took in sunlight and exhaled oxygen. At first, this oxygen rusted the iron dissolved in the oceans, staining the seafloor with bands of red. But over time, it began to accumulate in the air. Millennia passed, and eventually, Earth began to breathe. This change was not subtle, it was catastrophic for everything that had come before. The Great Oxygenation Event, they call it. A mass extinction caused by too much oxygen, a poison to the life forms of the time, even as it was the foundation for the life forms yet to come. From this upheaval came a new world, one in which complex cells could thrive, in which energy could be drawn from sugar and fire. Oxygen gave rise to multicellular life, and eventually to us. And so we owe our breath to microbes, to the tiniest architects of the sky. The air around us today, roughly 78% nitrogen, 21% oxygen, and just a whisper of other gases, has been curated by life itself. It's not just something we live in, but something we live with, a living record of the planet's past, and a fragile agreement among all things that breathe. But what happens if that agreement falters? The balance is delicate. Consider carbon dioxide, a tiny fraction of the air, yet a powerful regulator of heat. Too much, and the planet warms. Too little, and we freeze. Our atmosphere filters sunlight, lets in warmth, traps some of it, and radiates the rest back to space. It filters out ultraviolet radiation with its ozone layer. It burns up meteors in its friction. It carries a sound, water, pollen, seeds. It connects every part of Earth in a web of weather, from equator to pole. But this shield is not guaranteed. Ozone holes, rising CO2 levels, aerosols, smog. These are the signatures of change, and though they may seem modern, they echo a deep truth. The atmosphere has always been in motion, always subject to flux. Sometimes the changes are natural. Volcanic eruptions can send ash and gas high into the stratosphere, dimming sunlight and cooling the planet for years. Massive eruptions in the past have altered climates, triggered extinctions, reshaped coastlines. Other times, it is life that alters the balance. As we saw with photosynthesis, the emergence of a new biological process can transform the air entirely. And sometimes, only recently, it is us. The Industrial Revolution marked the beginning of a new chapter in atmospheric change. Burning coal, oil, and gas released carbon that had been buried for millions of years. That carbon entered the air as carbon dioxide. The greenhouse effect, once a gentle blanket, began to thicken. Earth warmed. Slowly at first, then more rapidly. The signals are everywhere now: melting glaciers, rising seas, changing rain patterns, even the seasons shift. Spring comes earlier, storms grow stronger, droughts linger longer. These changes are not just weather. They are signals from the atmosphere that its balance is tilting. Yet even now it holds. Even now it protects. The sky is still blue. The air is still breathable. Birds still ride thermals. Children still fly kites. This is not the story of collapse. It is the story of possibility, of how even a thin layer of gas, spread like silk over a spinning rock in space, can create and sustain something as delicate and tenacious as life. And it reminds us that habitability is not simply about being in the right place in space. It is about being in the right state of change. A planet can orbit the perfect star, spin with perfect grace, and still fail to support life if its atmosphere falters. Venus, for instance, is often called Earth's twin, similar in size, composition, even distance from the Sun. but its atmosphere is dense with carbon dioxide, cloaked in sulfuric acid clouds. Surface temperatures are hot enough to melt lead. A runaway greenhouse effect transformed it from potential paradise to inferno. It teaches us, wordlessly, what can happen when the balance is lost. Mars, too, holds lessons. A smaller planet, it likely once had rivers, perhaps even lakes, but its weak gravity could not hold onto a thick atmosphere. Over time, solar wind stripped it bare. What remains is a thin whisper of carbon dioxide, unable to trap warmth, unable to protect. The water froze or evaporated. The rivers dried. Mars is still there, still beautiful, still mysterious, but not alive. Earth, unbalanced between Venus and Mars, is the rare success, the exception, the miracle. But miracles, even scientific ones, require maintenance, attention, care. So tonight, as you rest under this ancient sky, consider the atmosphere not as background, but as presence. Every breath you take is a conversation with ancient oceans and ancient forests. The nitrogen in your lungs came from stars that died long before Earth formed. The oxygen you used to dream was made by sunlit algae, still floating in the sea. The atmosphere is not just above us, it is within us. It connects all living things. It remembers what came before, and perhaps it whispers what's to come. Close your eyes again and let your awareness slip downward now, not into the stars or the sky, but beneath you, into the quiet solidity of the ground. It feels firm, dependable, cool if you touch it. But below the surface, the earth is not still, not truly. Beneath your resting place lies a world of fire and motion, hidden beneath the calm skin of continents and oceans. What seems like stability is only the surface of something ancient and ever-changing. Earth's interior is alive in a way that defies our senses, moving not quickly, but persistently, with a slowness that outlasts empires. The ground beneath you may feel eternal, but it rides on plates, immense slabs of crust, floating atop a mantle of hot, slow-moving rock. These tectonic plates shift, drift, collide, and part over the course of millions of years. They shape continents, raise mountain ranges, open oceans, and birth volcanoes. This motion is not random. It is driven by heat from Earth's core, by the restless energy left over from the planet's formation, and continuously produced by radioactive decay. Earth is cooling, slowly, over eons, and that cooling drives the movement of rock like thick syrup swirling in a pot too vast to see. Descend deeper, past the crust, and into the mantle, where solid rock moves in slow currents, like a great breath beneath stone. It is here that the plates gain their energy, drawn downward at subduction zones, rising again at mid-ocean ridges. The earth recycles itself. Crust becomes mantle. Mantle becomes crust. Nothing is wasted. Everything is transformed. And then, deeper still, into the outer core, a sea of molten metal, mostly iron and nickel, spinning and churning in endless circles. This is where Earth's magnetic field is born. The movement of conductive fluids in this layer generates a powerful field that extends far beyond the surface, creating a magnetic cocoon that protects us from cosmic radiation and solar wind. Without it, the atmosphere would slowly be blown away, just as it was on Mars. This magnetic field is invisible, but you can feel its effects in the compass needle that always points north, in the northern and southern lights that shimmer near the poles, in the shielding that allows life to exist on the surface without constant bombardment from the sky. At the very center of the planet, lies the solid inner core, hotter than the surface of the sun, yet under such immense pressure that it remains solid. It is here, in this sphere of iron no wider than the moon, that the heartbeat of the planet resides. The inner core grows slowly over time as the planet cools, a crystallizing heart that adds to itself grain by grain. Its growth subtly alters the dynamics of the outer core, changing the magnetic field, sometimes even causing it to flip, north becoming south, south becoming north. These reversals have happened many times in Earth's past, and though they do not bring disaster, they are a reminder that even the deep parts of the planet shift. This layered structure, the crust, the mantle, the core, is not just geology, it is life support. Tectonics regulate carbon dioxide through the long carbon cycle. Volcanoes release gases that replenish the atmosphere. Mountains erode and feed the oceans with nutrients. The mantle's convection keeps continents drifting, preventing the planet from becoming geologically stagnant. It is a system as vital in its way as the atmosphere above, but it is also a system with an expiration date. Earth is cooling. Slowly, yes, but inevitably. The heat that powers its internal engine is not infinite. One day, far in the future, the mantle will cease its motion. The tectonic plates will freeze in place. The magnetic field may weaken or disappear. The atmosphere will change. Volcanic outgassing will slow. Without tectonics, carbon dioxide could fall to levels too low for photosynthesis. Life could begin to suffocate, not in fire or flood, but in the quiet of missing breath. And this is not fantasy. We can see such fates in other planets. Mars, once geologically active, cooled too quickly. Its core solidified. Its magnetic field faded. Volcanism slowed to a stop. The atmosphere thinned and leaked away. With no tectonic movement, carbon cycling ceased. Whatever habitability it may have once possessed now lies buried under dust. The planet is not dead in the sense of motionless. Quakes still occur, but it is no longer active in the way that sustains ecosystems. Venus, by contrast, may still have some geological activity, but without plate tectonics, its surface seems to be shaped by massive episodes of resurfacing rather than steady recycling. Its carbon dioxide has nowhere to go. Trapped in its thick atmosphere, the greenhouse effect has run rampant, heating the planet to unbearable temperatures. So Earth, balanced delicately between these two fates, reminds us of how rare and specific our situation is. The heat within our planet sustains not just volcanoes and earthquakes, but the chemical equilibrium that makes oceans bloom and forests grow. It provides the long, slow exhale of gases that replaces what the atmosphere loses. It powers the dynamo of the magnetic field, which shields us from the sky's more dangerous offerings. And still, this internal warmth fades, not quickly, not soon. But one day, the planet will cool enough that these systems slow. Habitability is not just a matter of surviving from the outside in. It also depends on the warmth beneath our feet. Yet for now, the core churns on. The field still flickers. Volcanoes still rise. And as you lie in your bed, your home anchored to shifting crust, the planet's deep machinery continues its tireless dance. You may not feel the mantle moving, but it is always in motion, always humming, always dreaming in stone. It is a comforting paradox. This notion that the earth must move, must change, must be restless to be stable. Without that motion, the things we take for granted would vanish. The soil would turn sterile. The oceans would grow still, the sky would change its hue. So when the ground trembles beneath distant mountains, when a volcano erupts in a faraway land, it is not merely chaos, it is the sign of a living planet, breathing, adjusting, persisting. There is a kind of security in knowing that even in our deepest sleep, something far older and stronger is at work below us, something steady, something vital. And tonight, that warmth still radiates upward. The plates still shift in their slow waltz. The iron heart still turns. The living shield above and the restless fire below keep us in balance. Now lift again, gently, from the deep warmth beneath the ground back into the sky, but not as we did before, not into the stillness of space or the chemistry of the atmosphere, but into motion, the way air stirs and flows, the way clouds form, the way a breeze brushes your cheek and disappears like a passing thought. This is the realm of weather, a part of habitability that we rarely think of in terms of survival. And yet the way our sky moves, its breath and rhythm, its pressure and mood, is one of the most vital aspects of life on Earth. Picture the planet from above again, not as a blue marble, but as a dynamic body wrapped in constant motion. Air rises near the equator, where the sun strikes most directly, carrying warmth upward. That air cools as it climbs, forming clouds and dropping rain, then flows outward and sinks again around 30 degrees latitude in both hemispheres. These patterns form the Hadley cells, great invisible wheels of moving air that circle the planet in layers. Beyond them, other circulation cells take over, feral cells, polar cells. Each region with its own signature winds, its own rhythms. And it is through these air movements that heat is distributed around the globe. The equator absorbs the most solar energy, but it is not selfish, it shares. The air and ocean currents work in tandem to spread warmth toward the poles and bring cooler air back. This balance is what allows temperate forests to grow, deserts to form, and rainfall to nourish farmlands far from the tropics. Without these circulating patterns, the equator would bake endlessly while the poles froze harder and harder with each season. Weather is the day-to-day face of these massive movements. A cloud drifting across the sky is a local expression of a global system. A storm that forms over the ocean is shaped by air temperature, sea temperature, wind speed, pressure differences, variables that shift like the strings of a harp, tightening and loosening with each season, each anomaly. And when those strings are tuned just so, they can produce great symphonies of wind and water, monsoons that arrive on schedule, rains that nourish crops, breezes that keep the air moving through a forest canopy. But when those strings are pulled too far, they can snap. Take El Niño and La Niña, the Pacific Ocean's twin moods. Every few years, surface temperatures in the equatorial Pacific shift, sometimes warming, sometimes cooling. These changes seem subtle at first, just a few degrees, but their effects ripple outward like quiet waves growing stronger with each ring. Rain falls where it shouldn't. Drought strikes where it's least expected. Wildfires rage in one hemisphere while floods surge in another. Crops fail. Fisheries collapse. Entire regions feel the breath of distant water. These are natural cycles, part of Earth's complex climate machinery. But they show us how interconnected everything is, how a change in the ocean's skin can alter the air over distant mountains, can delay the rains in one country and send hailstorms to another. The sky is not local, it is global. It is a system that binds every country, every creature, every landscape into a shared experience. And then there are the jet streams, fast moving rivers of air high in the atmosphere, slicing across continents. They guide storms, mark the boundaries between warm and cold air masses, and help regulate temperature. But as Earth warms, these streams can weaken, wobble, become more erratic. Sometimes they stall, letting heat linger in one place, or cold sit too long in another. This can lead to extended heat waves, polar vortex dips, or stagnant air that thickens with pollution. The sky loses its rhythm, and the effects reach down into the most ordinary corners of human life. Still, even these shifts do not mean uninhabitability. Not yet. But they hint at how delicate the system is. Climate change is not a matter of warmer days alone. It is a matter of disrupted motion. Rain where there was none, drought where there was once abundance, patterns lost, seasons confused. And when farming depends on the rains arriving on time, when rivers fill from melting snows that may never come again, habitability becomes a question not of existence, but of consistency. A place can still be alive, and yet no longer suitable for the ways we live. Think of the Sahel in Africa, a region once more verdant, now struggling with creeping desertification. Or California, where rainfall is increasingly feast or famine, wildfires more frequent, droughts more severe. Or the Arctic, where melting ice alters jet stream behavior and opens sea routes once blocked for millennia. These aren't just headlines. They are signs that the dance of wind and water is shifting, that the comfort we once trusted may not always be there. And yet, the weather still tells stories. The first chill of autumn, the heavy air before a summer thunderstorm, the sudden hush before snow. These are not just phenomena. They are memories etched into the sky. Your skin remembers them. Your bones remember them. They have shaped how we build, how we plant, how we gather, how we dream. Weather is not just data. It is experience. And perhaps that is why changing weather patterns affect us so deeply. We may not notice a gradual rise in average global temperature, but we do notice when spring blooms too early, when mosquitoes linger into winter, when hurricanes no longer behave like they used to. The emotional landscape of weather is tied to the emotional landscape of memory. When it shifts, we feel displaced, even if our homes have not moved. So what does it mean for Earth to become uninhabitable? It does not require the sky to fall or the oceans to boil. It may simply mean that the weather becomes something we can no longer predict, no longer endure. Crops fail not from lack of sunlight, but from the wrong kind of sunlight at the wrong time, under a sky that no longer remembers how to balance itself. Still, we remain in motion. The winds still carry seeds. The rain still falls in many places. The sky still shelters us, even as it stirs with new patterns. And we, like the animals and trees and grasses, must listen to the wind, to the temperature, to the shifting dance of clouds, because the weather is not separate from us. It is a part of our lives as much as breath. Tonight, the wind may whisper against your window. It may not say anything you can understand in words, but in its movement, in its direction, in its stillness or its speed, it tells a story of oceans far away, of heat rising from the land, of the world adjusting itself again. And as you listen, drifting into sleep, remember, the wind has always moved this way, carefully, responsively, lovingly. It only asks that we listen before it forgets how to sing. Let us lift again, slowly now, and drift outward, not just above the clouds or beyond the curve of Earth, but far into the black stillness where no air moves and no sound travels. Out here, space does not hum, it waits. The stars shine without flicker, ancient and unblinking. Earth floats below, wrapped in its gauze of air and life, a fragile sphere suspended in the dark. But space is not empty. It is not silent in the language of physics. It is filled with motion, with fragments of ancient collisions, with comets and asteroids, and the long trails of debris left behind by the birth and death of other worlds. Earth moves through this field like a dreamer wandering across a frozen pond, never knowing if something beneath might stir. We are used to thinking of habitability as something we shape or lose through our own actions or through slow shifts within Earth itself. But sometimes the most profound changes come from beyond. Earth has been struck before, suddenly, violently, by visitors from space. Not malicious visitors, not even intentional, just pieces of rock and ice, wandering by gravity, caught in Earth's pull, falling from a cosmos that neither knows nor cares. One such visitor changed everything. 66 million years ago, a rock about 10 kilometers wide, a cosmic grain of sand in the scale of the universe, came barreling toward Earth. It struck near what is now the Yucatan Peninsula in Mexico with a force beyond comprehension. The impact released more energy than 1 billion atomic bombs. It vaporized rock, sent firestorms racing across continents, lifted dust and sulfur high into the sky, and blotted out the sun for months or even years. The result was an extinction so complete that nearly 3/4 of all species vanished, including the great dinosaurs whose bones now rest in stone museums and forgotten riverbeds. And yet, out of that loss came a new beginning. Mammals rose to fill the empty niches, forests changed, oceans shifted, and eventually we came to be. But that transformation came not from slow evolution alone. It came from catastrophe, from a moment of planetary upheaval, from a chance encounter with a rock from space. This was not the only time Earth has been struck. Craters pockmark its surface, some ancient and worn by time, others fresh and sharp. The moon's cratered face is a testament to how often impacts occur when there is no atmosphere to burn the small ones away. Earth is protected, to a degree, by its atmosphere and by the vastness of space itself. Most rocks burn up before reaching the ground, becoming meteors that streak across the sky, fireflies of the cosmos. But a few make it through, and once in a while, one is large enough to alter the climate, the surface, or even the trajectory of life. We call them low probability, high impact events, and they are, in some sense, part of the cosmic lottery that all planets play. The solar system is not static. Objects drift, orbits evolve. Gravitational nudges from giant planets, like Jupiter, can send asteroids inward from the asteroid belt or dislodge comets from the Oort cloud, that distant sphere of icy objects surrounding our system like a bubble of forgotten things. Earth is hit not because it is cursed or chosen, but simply because it exists in motion, because to be a planet is to move through debris, to live in a sky where the stars hold old memories and occasional surprises. We now track many of these near-Earth objects, scanning the heavens with telescopes, plotting trajectories, modeling risks, and the truth is comforting. For now, no known object threatens us in the near term, but space is wide, And even with our vigilance, we see only a fraction of what's out there. Something could come tomorrow, or not for a million years. We simply do not know. And so we prepare, or imagine ways to prepare, deflection missions, impact mitigation, international cooperation. But mostly we wait and watch. Could Earth become uninhabitable from such a strike? Yes. Depending on the size and speed, the location and timing, an asteroid or comet impact could disrupt global climate, destroy ecosystems, ignite global fires, poison the air or ocean. It could bring not just extinction to species, but collapse to civilizations. The loss of sunlight alone, from dust and aerosols lofted into the stratosphere, could halt photosynthesis for months. Crops would fail, food chains would break, the sky would darken not with storm, but with silence. And yet, such events are rare, extremely rare. They shape the story of life only in long arcs, once every many millions of years. For all our fears, most of Earth's days pass unstruck. The moonlight falls without interruption. The seasons roll gently forward. But the possibility remains, like a sleeping dragon at the edge of the map, not because it must wake, but because it might. There is a strange comfort in that possibility, too. It reminds us that we are part of a larger cosmos, that Earth is not a closed system, but a traveler like us, subject to the whims of a wider sky. It reminds us, too, of resilience. Life has recovered from impacts. Earth has continued to breathe, even after catastrophe. And so, on clear nights, we watch the sky. We see shooting stars, tiny bits of dust burning up in the atmosphere. We make wishes, though the stars themselves are unaware. We look at the moon, marked by scars of long ago impacts, and we do not fear it. We send probes to asteroids. We study craters. We learn piece by piece the story of cosmic hazard and survival. You may never witness an impact in your lifetime. You may never hear the sudden roar of a rock from the stars arriving without warning. But every day, the Earth is peppered with tiny fragments, dust, stone, iron, that fall unseen. They are not threats, they are whispers. They remind us that the planet is not only a product of what happens within, but also of what comes from without. So tonight, as you drift toward sleep, imagine the sky above you, not just as a canvas of stars, but as a moving sea of ancient things. Imagine the planet riding its orbit with grace, spinning and sailing through a vast, silent ocean. We are not alone here. The universe is full. But Earth, small as it is, carries life still. And for now, the sky remains quiet. Let us descend again from the vastness of space, slowly, like a feather falling through layers of air, quiet and undisturbed, until we arrive back home, where the grass grows, where cities flicker with light, where the oceans inhale the sky. Let us come back to now. Not to distant cataclysms or future suns, but to the warmth that fills the air around us tonight. It may feel pleasant, even comforting, but that warmth carries a question. It is not the ancient warmth of Earth's inner fire or the rhythmic pulse of a changing season. It is something new, something accumulating. Earth has a fever. It is low, steady, rising, not in a dramatic wave, but in a slow tide, a subtle thickening of heat, noticeable only over years, decades, lifetimes. And like any fever, no, it is not the disease, but a sign that something is changing in the balance between energy in and energy out, in the way the planet holds the sunlight we have always needed to live. To understand this warming, we must begin with something as familiar as daylight. Every day, sunlight strikes the earth. Some of that energy is absorbed by the surface, warming land and ocean. Some is reflected back into space by clouds, snow, or bright deserts. And some is re-radiated in the form of infrared energy, heat, which escapes outward through the atmosphere and back into the void, but not all of it. Certain gases, carbon dioxide, methane, water vapor, trap some of that infrared heat, holding it close to the surface. This is the greenhouse effect, and it is not a flaw. It is what makes Earth habitable. Without it, our average temperature would be far below freezing. The oceans would be locked in ice. Life as we know it could not exist. The issue then is not the presence of greenhouse gases, it is the excess. Since the dawn of industrialization, we have released vast amounts of carbon dioxide and other gases into the atmosphere. We have done this by burning coal, oil, and natural gas, fossil fuels formed from ancient forests and plankton buried long ago and transformed by pressure and time. In using this stored energy, we have also released the carbon locked away for millions of years. The atmosphere, once in a long, slow conversation with the oceans and forests, has been jolted. The concentration of carbon dioxide is now higher than it has been in at least 800,000 years, perhaps longer, and it continues to climb. This change may seem abstract, a few hundred parts per million, but it alters the planet's thermostat. More heat is trapped. The oceans absorb much of it, delaying the full effects. But the surface warms. The Arctic melts, glaciers retreat, permafrost thaws, sea levels rise, and weather, once steady and seasonal, begins to shift. The signs are everywhere now, subtle and visible at once. Coral reefs, vibrant and teeming with life, bleach under the stress of warmer waters. Forests in drier regions burn longer, hotter, more often. Storms intensify as warm air holds more moisture. Heat waves shatter records once thought unbreakable. Entire summers swell with temperatures that stretch the definition of comfort and strain the limits of endurance. And it is not evenly distributed. Some places become wetter, others dry beyond recognition. Some storms grow slower, stalling over coastlines and pouring out a year's worth of rain in a single day. Others gather heat and speed, whipping across oceans with greater fury. The atmosphere, energized by a warmer world, holds new kinds of memory. Its patterns become harder to predict, less anchored in the rhythms we have long understood. And yet, this is not apocalypse. It is transformation. Earth is still very much alive, still habitable, but the conditions that shaped our civilizations, the relative stability of climate over the last 10,000 years, the gentle pendulum of seasons, the predictability of rain and harvest, are beginning to shift. This is the question at the center of our story. What does it mean for Earth to remain habitable if it no longer behaves in the ways we've always known? We are, after all, a species that has grown used to the margins of temperature, rainfall, and soil. Crops need a certain number of frost-free days. Rivers depend on mountain snowmelt. Cities are built with assumptions about flood levels, storm frequencies, summer highs. Those assumptions are being rewritten quietly, incrementally, not with catastrophe in every case, but with unease. What was once rare becomes usual. What was once usual becomes strained. And with this warming comes feedbacks, those secondary effects that make change faster or deeper. As ice melts, it reflects less sunlight, allowing more heat to be absorbed. As permafrost thaws, It releases methane, a potent greenhouse gas. As forests burn, they release carbon that had been locked away in trunks and roots. Each of these processes nudges the balance further from the old state, creating new dynamics that are harder to control. Some feedbacks might slow warming, forest regrowth, carbon uptake by oceans, even certain kinds of cloud cover may act as stabilizers. But many of the strongest feedbacks move in the direction of amplification, not moderation. And this is why warming matters. Not because a single degree of temperature is fatal, but because of what it signals. It is the gentle tilt of a system moving toward a new equilibrium, one that may be less friendly to the way we live. Even so, the Earth is not angry. It does not punish. It simply responds. The warming we face is not irreversible, but it is persistent. Carbon dioxide lingers in the atmosphere for centuries. The oceans take time to adjust. The heat already stored will continue to influence weather and ecosystems for generations. What we do now matters not just for tomorrow, but for the far horizon, for the kind of Earth our descendants will inherit, and for the ways they will need to adapt. And still, the planet remains beautiful. The air still stirs with birdsong. Rain still falls with its ancient rhythm. Trees still leaf out in spring. Earth is not lost. It is warming. And that distinction matters, because in that space between habitability and uninhabitability lies the realm of action, of stewardship, of care. Tonight, as you breathe gently in your sleep, that same warmth touches fields and forests far away. Somewhere, ice melts in silence. Somewhere else, seeds open in soil newly warmed. The earth continues to turn, not broken, but changed. And we, still here, still dreaming, still learning, hold a fragile power to notice, to respond, to hope. The earth is still quiet tonight, and your breath, soft and slow, mirrors the rhythm of waves somewhere far away, waves that rise and fall as they have for millions of years, touching the shores of every continent with salt and time. But listen carefully. The rhythm is changing. The tides are creeping higher. The land, once solid and familiar, is beginning to shift beneath our feet. This isn't the loud, sudden upheaval of a storm or a quake. It's something gentler and more patient, a slow rearrangement of boundaries, a reshaping of maps, a subtle redrawing of what it means to live on the edge. Sea level rise is not something most people feel on a daily basis. It doesn't knock on your door like a storm. It doesn't crack the sidewalk like a quake. But it arrives just the same, inch by inch, tide by tide, year by year. And when it does arrive, it brings with it not just water, but memory. It reminds us that coastlines are not permanent, that harbors, ports, beaches, even cities are all built on agreements with the sea, agreements that can be broken. As the planet warms, glaciers and ice sheets melt, not in sudden collapse, but in a long, slow surrender. Ice that has held firm for thousands of years is softening. The Greenland ice sheet, the glaciers of the Andes, the ancient ice of Antarctica. These are not just masses of frozen water. They are libraries of Earth's history, time layered into every flake. And as they melt, their stored water flows downward, eventually reaching the sea. Add to this the expansion of seawater itself, warmed by accumulating heat, and the oceans begin to swell, not by feet overnight, but by millimeters that add up over decades. Low-lying nations like the Maldives and Tuvalu already feel the breath of the rising sea in every tide. Salt water intrudes into freshwater aquifers. Crops begin to wither in soils no longer sweet. Homes are rebuilt again and again, just inches higher each time. Elsewhere in coastal cities across the globe, Jakarta, Miami, Bangkok, streets flood more frequently, not just during storms, but during ordinary high tides. These floods are not disasters in the old sense. They are inconveniences becoming norms, quiet emergencies that remind us the sea no longer waits at the edge. But it is not just the rising water, it is what is lost beneath it. Wetlands vanish, taking with them the birds and amphibians that once nested there. Mangrove forests, which once shielded coastlines from erosion and storms, drown when they can no longer keep pace with the sea. Coral reefs bleach and crumble as warmer waters strip them of the algae that give them color and life. These reefs, some of the most diverse ecosystems on Earth, are not just victims of rising seas, but of warming seas. The heat seeps into them, and their intricate balance collapses. Farther inland, other transformations unfold. Forests, vast, ancient, self-sustaining, begin to thin and retreat. Droughts lengthen, fires burn hotter more often. Insects, once kept in check by winter frost, spread unchecked, killing trees faster than they can regrow. The Amazon, sometimes called the lungs of the earth, breathes with less strength each year. Parts of it now emit more carbon than they absorb, as deforestation and warming tip the balance. Boreal forests in Canada and Siberia burn in flames that reach the sky, releasing not only carbon, but memories buried deep in moss and soil. Habitability is not only about whether a place has water or air. It is about whether the systems we depend on, forests to store carbon and give us air, oceans to regulate temperature, wetlands to filter and protect, can continue to function. As they weaken, we do not merely lose beauty. We lose buffers, regulators, lifelines. In some places, ecosystems shift. Tundra becomes shrubland, grasslands turn to desert. Species migrate uphill or poleward, chasing climates they once knew. But not everything can move. Not everything can adapt. Trees rooted in place, amphibians tied to the rhythm of rainfall, coral that cannot walk away. These beings remain, enduring what they can, fading when they must. Extinction, in these cases, is not sudden but quiet. An absence where there once was a presence, a silence where there once was song. And humans, too, are shaped by these changes. Agriculture depends on rainfall patterns that no longer arrive on time. Coastal communities must weigh the cost of staying versus leaving. Insurance companies redraw their coverage zones. Some homes become uninsurable. Some neighborhoods too costly to protect. And slowly, the idea of a permanent place, of roots that stretch generations deep, begins to feel uncertain. Yet even in this shift, life persists. Salt-tolerant plants colonize new marshes. Species arrive where they've never been seen before. Humans experiment with floating farms, with climate-resilient crops, with artificial reefs. Adaptation is not impossible, but it is uneven. It favors the wealthy, the prepared, the mobile, and it leaves behind those who lack resources, those whose homes were always near the edge, those whose languages and cultures are tied to lands now washing away. And so we come again to the idea of habitability, not as a single line between livable and not, but as a gradient, a slope that many are already sliding down. Earth remains generous, but her generosity is changing shape. The planet will still support life, but the question becomes which life, where, and for how long? None of this is distant. None of it is in some far off corner. The changes are happening now, in forests that no longer green as they once did, in coastlines redrawn not by maps, but by the tide. And still, the world holds beauty. Still, birds sing at dawn. Still, the sky opens each morning and closes each night. But the margins are fraying. As you sleep, the oceans continue their slow ascent. Forests rustle in darkness, some untouched, some burning. Somewhere, a family places sandbags along a doorway, not in fear, but as part of the routine. The tide comes in, and the water rises, not like a wave, not like a roar, but like a breath held a little longer than before. Imagine the quiet hum that lingers in a city after midnight, when most have gone to sleep, but the machines remain awake. Somewhere, traffic lights change with no one watching. Street lamps cast their pale glow on empty sidewalks. Elevators rest in their shafts. Computers pulse gently behind closed office doors. Even when we sleep, so the cities do not. They breathe in their own way, through engines, pumps, grids, wires, and in their breath is a reflection of how humans have shaped the surface of the earth. Cities are not natural, but they are not entirely separate from nature either. They are built from the bones of the planet, concrete from limestone, steel from ore, glass from sand. They are ventilated by air currents and warmed by sunlight or cooled by water drawn from rivers and reservoirs. But they function differently from forests or plains. Where a forest breathes carbon in and oxygen out, a city breathes energy, information, waste, and heat. It metabolizes resources, transforms them into movement, into growth, and into light. And in doing so, it leaves behind traces, heat islands, carbon plumes, altered wind patterns, sounds that never stop. Urban areas now house more than half of the world's population. And though they occupy a small fraction of Earth's surface, they exert a growing influence over the planet's systems. Cities are concentrations of innovation, culture, and adaptation. But they are also vulnerable. Their design assumes a certain stability of weather, of water availability, of sea level. And as that stability shifts, so too must the cities, or they begin to falter. The most immediate change is temperature. Urban heat islands occur because roads, rooftops, and concrete surfaces absorb heat during the day and release it slowly at night, keeping city temperatures higher than the surrounding countryside. In a warming world, this effect becomes amplified. What was once a tolerable summer day becomes unbearable. Night no longer offers relief. Air conditioners hum louder, drawing more electricity, often from power sources that release more greenhouse gases in turn. Then comes water. Some cities face too much. Monsoon rains overwhelm storm drains. Hurricanes bring storm surges that leap over seawalls and flood subway tunnels. Others face too little. Prolonged droughts shrink reservoirs, and water restrictions become the new normal. Groundwater is pumped from ever deeper aquifers, causing the land itself to sink, millimeter by millimeter, until roads crack and buildings lean. And beyond water and heat is the web of systems that modern life depends on: electricity grids, transportation networks, food supply chains, digital infrastructure. Each of these systems assumes certain parameters: that the power stations will stay cool enough to function, that roads will remain above water, that crops grown hundreds of miles away will be delivered on time. As climate patterns shift, these assumptions are tested. Yet cities are also centers of adaptation. Green roofs are planted with vegetation to cool buildings and absorb rainfall. Streets are redesigned to allow water to flow away more safely. Urban farms grow food in stacked trays or on vertical walls. Some cities experiment with sponge infrastructure, parks and wetlands designed not to resist water, but to absorb it. Others build sea walls, raise buildings, or move entire neighborhoods. Technology hums beneath these efforts, offering data, predictions, alerts, but always, behind the machinery, is the quiet urgency of humans trying to reshape their environment before the environment reshapes them. And still, there is the question of equity. Not all parts of a city are affected equally. Heat pools in poorer neighborhoods with less tree cover. Floodwaters rise higher where infrastructure has been neglected. Adaptation costs money, and those who have the least often face the highest risks. This is the shadow of habitability, not just a question of whether Earth remains livable, but for whom. A city may still function, its lights may shine, but the experience of living within it may differ drastically across neighborhoods, across incomes, across time. There is something deeply human in our desire to make machines mimic the functions of nature. We build air filters that purify like forests. We construct desalination plants that provide water like rivers. We design biospheres and greenhouses and oxygen generators. In laboratories, researchers work on artificial photosynthesis, trying to recreate the miracle of a leaf. These efforts are not folly. They are necessary, even beautiful. But they remind us of something sobering: how difficult it is to replicate what nature does with ease. A single tree cools its surroundings through evaporation, absorbs carbon, provides shade, supports birds and insects, and grows in silence, asking nothing. To mimic that with machines is possible, but rarely efficient. The city may never breathe like a forest, but it can learn. Green spaces, permeable surfaces, energy efficiency, biodiversity corridors, each is a way to bring the lessons of nature into the heart of the built world. But as the Earth's climate continues to change, there is a deeper question beneath the technologies and the planning documents. Can we build places that remain livable in a world that is no longer predictable? Can our machines compensate for what is being lost? Can our cities adapt not just structurally, but culturally, embracing new rhythms, new ways of living, new relationships with the land and sky? We are learning, slowly, sometimes too slowly, but the knowledge grows. And with it, so does the understanding that the most resilient cities are not just the ones with the tallest seawalls or the deepest tunnels, but the ones with the most community, the most flexibility, the greatest capacity for change. Tonight, while you rest in your own corner of a city, or a town, or a village, machines hum in the background, circulating air, cooling water, powering lights. They do not sleep, they serve, but outside, in courtyards and parks, in quiet alleyways and rooftop gardens, something else breathes too. Leaves turn toward the moonlight, cats curl on warm stone. The city lives, not just through steel and circuitry, but through every small act of persistence. Earth remains habitable, in part because we continue to imagine how to live within it, how to build in harmony rather than opposition. And while machines may help us survive, it is memory, compassion, and creativity that will help us belong. And now we look upward again, beyond the clouds, past the hush of the atmosphere, into the deeper silence where our planet's truest companion resides, the sun. That steady, ancient flame, that unblinking eye that warms our days and commands our seasons, is far more than a backdrop to life. It is the source, it is the rhythm, and in the vast reach of time, it too is changing. We rarely consider the sun's story. It seems immutable, always rising, always setting. But the sun, like all stars, is not fixed. It is a thermonuclear engine, fusing hydrogen into helium at its core, releasing light and heat that has traveled for 8 minutes through space to reach the leaves on a tree, the skin on your cheek, the waves on an afternoon sea. This fusion has powered the sun for over 4 billion years, and it will continue to burn for billions more. But slowly, imperceptibly, its light grows stronger. The sun is in what astronomers call its main sequence phase, the long, stable period in a star's life when it quietly turns hydrogen into helium. During this time, its brightness increases by about 10% every billion years. This doesn't sound like much, not to a universe that measures things in cosmic time, but to a planet like ours, balanced so delicately in the narrow band of habitability, it is enough. As the sun brightens, more energy reaches Earth. Over time, this extra energy begins to accumulate. Weather patterns shift, oceans warm, the carbon cycle adjusts. The biosphere begins to feel the press of that gentle but relentless light. And eventually, somewhere between 1 and 2 billion years from now, the warming becomes too much. Not in the sudden way of a fire, but in the slow persistence of a rising tide. The Earth may still orbit at the same distance, but the Goldilocks zone will have moved, and we will find ourselves on the wrong side of warmth. One of the first major consequences of this slow solar brightening is the moist greenhouse effect. As temperatures rise, more water evaporates from the oceans. Water vapor, itself a potent greenhouse gas, traps more heat. The cycle feeds itself. Eventually, the stratosphere begins to hold water, a layer of the atmosphere that today is kept dry by the cold. In that new future, sunlight breaks these high-altitude water molecules into hydrogen and oxygen. The hydrogen, the lightest element, escapes into space. Slowly, the Earth begins to lose its oceans, molecule by molecule, to the stars. This is not speculation alone. We've seen echoes of this process elsewhere. Venus, our sister world, may once have had oceans, but with no magnetic field, with a thickening atmosphere with an orbit slightly closer to the sun, it entered a runaway greenhouse phase. Its water was lost. Its skies thickened. Its surface became hot enough to melt lead. Venus is not a cautionary tale from science fiction. It is a real planet, visible in our evening skies, offering a vision of what can happen when balance is broken. For Earth, the changes will be slower, drawn out over millions of years. But the trajectory is set. Even if we were to halt all human-induced warming, even if we lived with perfect harmony and balance, the sun's growing light will one day render our planet uninhabitable, not from war or famine or failure, but simply from the aging of a star. Eventually, in 4 or 5 billion years, the sun will leave its main sequence. It will exhaust its hydrogen and begin fusing helium, swelling into a red giant, expanding past Mercury, past Venus, and perhaps even engulfing Earth. The oceans will have long since boiled away. The atmosphere will be lost. The surface will be scorched. The memory of forests and rivers, birds and language will fade into heat and dust. But that is not tonight. Tonight, the stars still shine above us, steady and quiet, and the sun, though aging, remains a faithful companion. We live in a golden moment between formation and decline, between chaos and stillness. A window of time so wide to us, yet so narrow in the life of the planet. This knowledge does not bring despair, it brings clarity. It reminds us that everything we know and love, the music of insects in the summer dusk, the hush of snowfall, the warmth of a morning sunbeam, exists because of a perfect alignment in space and time. And because this alignment will not last forever, it is all the more precious. It also reminds us that habitability is not just about what we do, but about what the universe does. There are forces beyond our control: stellar evolution, orbital mechanics, cosmic radiation, that shape the boundaries within which life can flourish. And in that context, our role is not to stop change, but to understand it, to live wisely within it, and to prepare, if we can, for what lies beyond. There are dreams, of course, dreams of moving to Mars, of building habitats in space, of finding new Earths among the stars. These are dreams for another night, perhaps, but they begin here with the knowledge that even the most perfect planet has its limits, that no home lasts forever, that the sun, generous and radiant, carries within it the seeds of eventual farewell. But for now, Earth remains. Its sky still holds its blue. Its oceans still carry the song of whales. Its forests still breathe. And its people, curious and watchful, still gaze upward, wondering what comes next. So sleep tonight under a sky that has not changed. Let the warmth of the day linger on your skin. Know that the light that woke the flowers this morning was born in the sun's core 10 million years ago and traveled across space just to touch this one spot, this one world, you, here. And though the clock in the sky ticks onward, slowly, inevitably, the hour is not yet late. Earth is still here, and we are still home. What if we stepped away for a moment, not from the room or the day or the story, but from the idea of ourselves entirely? What would the earth be without us? Not in some sudden erasure, not in the cinematic hush of empty cities overtaken by ivy, but in a quiet, graceful absence, as if humanity had simply paused and never returned. What would happen if we were no longer here to build or burn, to dam or dig, to farm or fell or sing or stir? The earth, in its own time, would go on. Grass would push up through sidewalks, finding cracks to widen, shade to reach toward. Seeds blown from abandoned gardens would take root in the softening soil of forgotten suburbs. Trees would grow through the shells of buildings, their roots heaving through floorboards, their branches brushing walls that once framed windows. Animals, long kept to the edges, would wander freely again. Deer on highways, foxes in courtyards, wolves where fences once stood. Without maintenance, our human structures would falter. Power grids would fail within days or weeks. Without the constant labor of cooling and monitoring, nuclear plants would shut down, or in some cases melt down, their toxic breath leaking into air and soil. But even this would not be permanent. The chemicals we leave behind, the plastics, the concrete, the metals, they would linger for centuries, some for millennia. But they too would wear away, scoured by wind, buried by dust, digested by bacteria we have only begun to understand. The earth would bury us gently, not out of malice, but out of motion. In time, rivers would find old paths again. Dams would break. Wetlands would reclaim land that had been paved and drained. Birds would fill the skies not darkened by smog, and oceans would swell with fish where nets no longer drag. Coral reefs might recover, given centuries of calm. Forests would spread unevenly, reaching back across lands once cleared for agriculture, though not all forests would return the same. Some trees are already lost to extinction. Some seeds require animals that no longer roam. The scars we leave are not all ones the earth can heal, but still, life would return. It always has. The earth has known mass extinctions before, 5 great ones, perhaps more. Each time the biosphere collapsed, and each time it recovered, not with the same cast of characters, but with new ones. After the asteroid that ended the age of dinosaurs, mammals emerged into the open. After the Great Dying at the end of the Permian, which saw 90% of marine species vanish, coral reefs slowly reformed with new builders. Life is not a single script, but an improvisation played across eons. So in our absence, Earth would not be destroyed. It would be transformed. Some places would become wilder, others quieter. The cities we leave behind would decay into geological curiosity. Future species, if any come to reason and reflect as we have, might one day uncover rusted beams and fossilized plastic and wonder what kind of creatures once walked this world and filled it with stories. The Earth does not require humanity to be habitable. That's an idea we often forget. We imagine the planet's value in terms of what it offers us: food, air, beauty, shelter. But Earth is not defined by our presence. Its rivers flowed before we named them. Its skies turned before we mapped the stars. Its volcanoes sang long before the first drum. And so, habitability is not just about sustaining us. It is about the ongoing capacity to support life. Life in its full, indifferent, glorious variety. Earth is likely to remain habitable for millions of years after we are gone. Bacteria will still divide. Insects will still hum. Mosses will still soften the edges of stone. But if the earth can thrive without us, then the harder question becomes, can we thrive without a habitable earth? We are not separate from our environment. We are not guests here. We are part of this system, bound into its cycles and woven into its breath. We inhale the same oxygen that leaves the pores of a leaf. We drink the same water that once pooled in ancient seas. The carbon in our bones may once have formed part of a mountain, or a fish, or a fern. We are not above nature, nor beneath it. We are inside it, and that understanding brings humility. If Earth could carry on without us, then our responsibility is not to preserve it for its own sake, but to preserve the conditions that allow us to remain part of its story, to stay in the orchestra, to continue the melody we've only just begun to understand. There are some who believe that technology will save us from environmental collapse, that we can engineer our way out of warming, sea rise, extinction, and perhaps, to a point, we can. But there is no technology that can replace the totality of Earth's systems. No machines as complex as a forest, no algorithm as adaptive as evolution, no network as robust as an ecosystem left to balance itself. And so the question of Earth's habitability becomes not just a planetary question, but a personal one. How long do we wish to stay? And in what kind of relationship with this world? Tonight, the world continues to turn. The winds still carry the scent of rain or sand or pine. Somewhere an owl stirs in the darkness, unbothered by the cities far away. Somewhere else, algae bloom in a pond, feeding small fish that feed larger ones. The sky, though dimmed in places by light, still opens its vault of stars. And here you are, breathing, warm, and present. This planet does not need you to survive, but you need it, its soil, its seasons, its rhythms, its resilience. And in knowing that, there is no shame, only a deeper, quieter awe. Earth without humans would still be Earth, but humans without Earth would be a fading echo. And now, let us drift inward, not into stone or space, but into the thinnest, most vital layer of all, the biosphere, a whisper of life clinging to the planet's surface, a delicate envelope no thicker than a coat of paint if Earth were shrunk to the size of a globe. And yet within that fragile layer pulses the full breath of life, ancient and ongoing, weaving together forests and fungi, whales and wasps, mosses and microbes in a dance as old as sunlight on leaves. The biosphere is not a place, but a process. It is the collective living skin of Earth, the part that takes in sunlight and transforms it into sugar, that exhales oxygen into the sky, that feeds itself and dies and feeds itself again. It is the coral reef, building its skeleton from calcium, the mycelial web exchanging nutrients beneath the soil, the bees visiting blossoms and unknowingly stitching landscapes together. And it is not passive. It is not merely shaped by the climate or the geology. It shapes them in return. Consider the forests, not as a collection of trees, but as vast breathing systems. Each leaf draws in carbon dioxide, uses sunlight to convert it into sugar, and releases oxygen. Each tree stores carbon in its roots, its trunk, its canopy. Each forest, whether tropical or boreal, acts as a living reservoir, regulating the atmosphere, cooling the land, guiding the flow of water. Forests summon rain through evapotranspiration, creating their own weather. The Amazon, it's said, is a flying river, lifting moisture into the sky and carrying it thousands of miles. Now look closer. In the soil beneath your feet, countless microbes break down dead matter, returning nutrients to the roots of living things. Worms aerate the ground. Fungi extend filaments that connect trees into networks, a wood-wide web where signals of drought or disease can travel. Insects pollinate flowers, which turn into fruits, which nourish mammals, who disperse seeds, which grow again. Every thread is tied to another, and none can be pulled without others moving. The oceans, too, hold their breath. Phytoplankton, microscopic organisms floating near the surface, perform half the photosynthesis on Earth. Half. Every second breath you take comes not from a forest, but from these tiny marine drifters, dancing in sunlit currents, feeding krill that feed whales that die and fall to the seafloor, their bones nourishing life in darkness. The biosphere extends even to the deep, creatures thriving at hydrothermal vents, bacteria in polar ice, seeds asleep for centuries beneath the desert. This is habitability in its most intricate form, not a question of temperature or distance from a star, but of continuity, of renewal, of interdependence. The planet is not habitable in spite of life. It is habitable because of life. Life creates conditions for more life. Cyanobacteria oxygenated the atmosphere billions of years ago. Plants pulled carbon from the sky and cooled the planet. Animals evolved to shape ecosystems with their grazing, their dung, their footsteps. Even extinction makes room for renewal. And yet, the biosphere is not limitless. It depends on stability, of climate, of nutrient cycles, of time. A forest can recover from fire, but not if the fires come too frequently. Coral reefs can survive bleaching, but not if the water never cools again. Species can migrate, but not if the habitat ahead is paved or poisoned or fragmented. Resilience is not invincibility. It has thresholds, and when too many systems are pushed too far, the biosphere begins to fray. Today, we are seeing that fraying. Biodiversity is declining at a rate unmatched in human history. Extinctions, once rare and scattered, are now accelerating. Amphibians vanish quietly, pollinators decline, large mammals retreat into ever-shrinking patches. Even the insects that fill the air on summer evenings have grown fewer, their songs quieter. This is not the loss of beauty alone. It is the loss of function. Each species carries out a task, breaking down matter, dispersing seeds, stabilizing soil, controlling pests. Remove enough threads, and the fabric weakens. And with that weakening, the planet's ability to sustain us also dims. Fewer pollinators mean fewer crops. Fewer fish mean emptier seas and hungry communities. Fewer trees mean hotter cities, faster erosion, diminished carbon storage. The biosphere does not separate itself into wild and human. We are a part of it, and when it suffers, we do too. Still, the breath continues. Life is persistent. It can survive in boiling springs, in frozen deserts, in radioactive ruins. It can adapt, mutate, shift. But adaptation takes time, and climate change is speeding faster than many species can follow. Forests planted today may not survive the climate of 50 years from now. Animals may find their migration paths blocked by fences, roads, or cities, and humans, so skilled at altering the world, often struggle to live within the limits we've reshaped. Yet all is not lost. Restoration is possible. Forests regrow, wetlands return. Species reintroductions have revived entire ecosystems. Whales, once hunted to near extinction, are increasing again, their songs echoing through the oceans. Dam removal brings rivers back to life. Farmers plant hedgerows and native grasses. Cities add green roofs, pollinator corridors, living walls. The biosphere, if given time and space, responds. And so the question of Earth's habitability rests not only on temperature or sea level, but on whether we allow the living systems of the planet to keep breathing. Whether we treat forests not just as resources, but as lungs. Whether we see wetlands not as swamps to drain, but as kidneys that cleanse. Whether we regard the countless species not as ornaments, but as partners. Tonight, while you sleep, the biosphere hums all around you. Roots deepen in the soil. Bacteria divide unseen. Owls hunt. Seeds stir. The air you breathe is not just chemistry. It is the exhalation of leaves, of algae, of life doing what it has always done, transforming light into matter, decay into growth, silence into song. And in this quiet, as your own breath slows, remember that you are part of this system. A single thread, but a living one. The biosphere is not something you observe. It is something you join every time you wake, every time you walk beneath a tree, every time you listen to birdsong at the edge of morning. Let the air around you cool now, just a little. Let your mind drift into the memory of ice, not the gentle frost of morning windows or the smooth sheets of winter ponds, but the deep, global stillness of a frozen world. The earth, for all its vibrant warmth today, has not always been so welcoming. It has known colds, cold that sealed its oceans, that whitened the tropics, that turned its equator into a ring of ice. And it has also known heat, ferocious, humid, almost alien warmth when the poles wore ferns and crocodiles. These are not myths, but chapters in the story of our planet. The tale of habitability is not one of constancy, but of swings, of extremes. More than once in its long life, the Earth has entered what scientists call a snowball Earth phase, a time when glaciers extended from pole to equator, when nearly the entire surface was locked in ice. The most dramatic of these episodes occurred around 700 million years ago, during the Cryogenian period. For tens of millions of years, the oceans may have been sealed beneath a thick crust of ice. Sunlight reflected from the white surface, reducing warmth further. Even the tropics likely froze. It seems impossible. And yet, life endured, perhaps in cracks in the ice where light still reached, perhaps in thermal vents on the ocean floor, perhaps in small pockets of open water kept warm by volcanic activity. The biosphere thinned, but it did not disappear. And when volcanic gases finally built up enough carbon dioxide in the atmosphere, thousands of times more than today, the planet began to warm again. The ice retreated, and in the aftermath, life surged forward into new forms, as if released from a long, cold dream. This frozen world teaches us something profound, that Earth's climate can tip into radically different states, and that these states can last for eons. They are not brief seasons or even ice ages. They are planetary moods shaped by continental positions, solar input, atmospheric composition, and feedbacks that reinforce themselves. When ice spreads, it reflects sunlight, cooling Earth further. When carbon builds, it warms the atmosphere, melting ice, releasing more carbon. These feedbacks work both ways, and so, just as Earth has frozen, it has also burned. At other times in its past, Earth has been a greenhouse world. During the Paleocene-Eocene thermal maximum, around 56 million years ago, temperatures spiked globally. The Arctic was free of ice. Palm trees grew in Wyoming. Ocean acidity increased. Some species vanished. Others adapted or moved. It was a time of warmth so intense that deep ocean life was disrupted for thousands of years. And this, too, was driven by carbon released from the Earth itself, perhaps from methane clathrates or volcanic activity, overwhelming the planet's usual regulators. Even earlier, during the age of the dinosaurs, the world was warmer still. Sea levels were higher. Tropical conditions reached into mid-latitudes. Coral reefs flourished in places now too cold to support them. There was no ice at the poles. The planet was habitable, but it was different, and it was not a world we could easily live in today. These ancient shifts reveal the breadth of Earth's climate capacity. The line between habitable and uninhabitable is not fixed. It can move and has moved across vast ranges of temperature and time. The question is not whether the Earth can support life. It can in many forms, but whether it can continue to support us and the intricate web of life we have come to depend on in the places we have chosen to settle. Because even within these larger climate epochs, smaller shifts carry weight. A few degrees warmer can make agriculture impossible in one region, force migration in another, upset weather patterns elsewhere. The stability we've known is rare. The Holocene, the last 12,000 years of relative climate calm, has been the canvas on which all of human civilization has been painted. Cities, agriculture, calendars, culture, each built on the assumption of seasonal repetition, of predictable rainfall, of a climate that does not surprise us too greatly. But the past shows us that Earth has no obligation to remain in this state. What keeps us from tipping into another snowball or another hothouse? Balance. Plate tectonics, which cycle carbon through rock and ocean. Weathering, which draws carbon from the air as mountains erode. Forests and plankton, which absorb carbon and release oxygen. And now, us. We too have become a planetary force, altering carbon levels, changing land use, tipping balances that took millions of years to form. And we have the tools to understand this. Ice cores that hold ancient air, tree rings that record drought and flood, sediment layers that preserve pollen from long-lost forests. These records show the pulse of the planet over time. They show that climate has changed dramatically and that life has always followed, adapting or ending, rebounding or retreating. But time is key. In the past, even the great shifts occurred over thousands or millions of years. Today, we see changes in decades. The speed matters. When change comes slowly, ecosystems adjust. When it comes quickly, they fracture. Still, even in this knowledge, there is room for reflection, for peace. The Earth is not simply hurtling toward doom. It is moving through the same process it always has: cooling, warming, breathing. Our presence adds complexity, adds urgency, but not inevitability. If we understand these cycles, if we learn from the ice and the warmth, perhaps we can shape our future with more wisdom than reaction. Tonight, as you rest, the planet does not sleep. Ice sheets groan and melt. Forests release scent into the air. The oceans circulate with ancient patience. Somewhere, a glacier calves into the sea, echoing a sound that only a few will hear, but that the whole world feels, eventually. And above it all, stars wheel in their silent arcs, as they did through the hot epochs and the frozen ones, through every chapter of Earth's shifting story. The sky remains steady, even when the ground changes beneath us. Earth has been many worlds, and in each, life found a way. There is a temptation to think of Earth's great changes as arising only from vast, cosmic forces, tilting axes, shifting continents, swelling suns. But sometimes, the most profound transformations begin with something small, a trembling deep beneath the crust, a shift in a molecule, a mutation inside a single cell. The story of Earth's habitability has always been shaped not only by the grand and sweeping, but by the quiet and minute. A volcano, a virus, a dusting of ash in the sky. A tiny change in a complex system can ripple outward until it touches everything. Let us begin in the dark places, deep beneath mountains and oceans, where molten rock stirs like slow thunder that's waiting to rise. Volcanoes are not simply eruptions of fire. They are the breath of the planet's interior, the exhalations of heat and pressure that build up over centuries. Some erupt quietly, adding new land to islands. Others explode with a violence that reshapes the skies. In the year 1815, Mount Tambora in Indonesia erupted with such force that it cast ash into the stratosphere, dimming the sunlight around the globe. The following year became known as the year without a summer. Snow fell in June in New England. Harvests failed across Europe and Asia. Famine spread in places unaccustomed to hunger. All from a single volcano, one point on the map, one moment in geologic time, echoing across hemispheres. And Tambora was not the first. Around 74,000 years ago, the Toba eruption, also in Indonesia, may have triggered a volcanic winter that lasted years. Some scientists believe it reduced human populations to a tiny fraction of what they had been. If so, it was not extinction, but a bottleneck, a narrow passage through which humanity barely passed. And the earth, though shaken, remained. Volcanoes are part of the carbon cycle. Over long stretches of time, they release gases that warm the planet, counteracting the cooling of weathering. They build land, enrich soil, and even seed clouds with particles that shape rainfall. But their sudden bursts, unexpected, explosive, filled with ash and sulfur, can temporarily cool the planet, disrupt ecosystems, and, in rare cases, shift the course of history. Then there are the things we cannot see at all. In the early years of the 21st century, the world stopped, not because of war or weather, but because of something microscopic. A virus, carried from animal to human, traveled across borders faster than any ship or storm. Cities emptied, airplanes sat idle, hospitals filled. The COVID-19 pandemic showed how fragile our systems are, how closely knit our societies have become, how a change at the smallest scale can reach every corner of human life. And yet, viruses are ancient, older than humanity, older, perhaps, than many forms of cellular life. They exist at the edge of what we define as living, unable to reproduce on their own, yet capable of transformation. Some are destructive, some are neutral, some are beneficial, shaping immune systems, transferring genes, guiding evolution. In Earth's deep history, pandemics have come before. The Black Death, the flu of 1918, outbreaks lost to time. And each one has reminded us that habitability is not a guarantee simply because the air is breathable and the water flows. It depends also on the health of systems, biological, social, and ecological, that remain delicately balanced. Other small changes matter too. Consider the role of dust, tiny particles lifted by wind from deserts or volcanoes or fires. Dust reflects sunlight, carries nutrients across oceans, fertilizes distant forests, even helps form clouds. A drought in the Sahel can increase dust that reaches the Amazon, feeding its trees. Fires in Australia can darken the ice in New Zealand, speeding its melt. Everything connects, and sometimes the smallest link carries the most weight. Even species, the addition or removal of a single kind of organism, can shift entire ecosystems. The reintroduction of wolves to Yellowstone changed not only the populations of deer, but the course of rivers as vegetation recovered along the banks. The disappearance of pollinators threatens the food web far beyond their tiny wings. The arrival of invasive species, plants, insects, mammals, can tip the scales from resilience to collapse. These are not dramatic changes in the way we imagine asteroid strikes or mega eruptions, but they change what lives and what does not. They change the shape of habitability, and so the picture grows more intricate. Earth's stability is not held only by massive girders of tectonics in orbit, but by threads, millions of threads, woven by life, by chemistry, by chance. Cut enough of those threads, and the web begins to sag. Pull one, and others move. But fragility is not weakness. A spider's web can flex in the wind, can hold the weight of dew, can capture movement, and translate it into survival. Earth's systems are like that, flexible, responsive, sensitive, but only to a point. When we think about whether Earth will become uninhabitable, it's easy to focus on temperature or sea level. But equally important are these silent thresholds where a coral reef turns from vibrant to bare, where a forest stops absorbing carbon and starts releasing it, where a disease leaps from animal to human and finds a new world to move through. The Anthropocene, the age in which human activity is the dominant influence on climate and ecosystems, is an age defined not just by scale, but by sensitivity. We are powerful enough now to affect planetary systems, but still vulnerable to the smallest disruptions. We live in the space between control and chaos, and yet, this awareness brings with it a kind of wisdom. If small things can undo, then small things can also restore. A protected wetland, a vaccinated population, a native plant reintroduced, a forest allowed to regrow, a change in diet, a rethinking of how we build and move and share. The same mechanisms that amplify risk can also amplify healing. Feedback works both ways. Tonight, somewhere a volcano sleeps beneath a quiet hill. Somewhere a virus mutates silently in the body of a bat. Somewhere a bee carries pollen from one blossom to another, completing a cycle that feeds a village. These are the scales on which habitability also depends. And as you breathe deeply and calmly, remember this. The world is not only shaped by forces beyond our reach, it is shaped by things we can touch, protect, and change. The grand arcs of Earth's history may be written in ice and fire, but the details, the living texture, are written in whispers. Let us wander now into the quiet fields, the ones that lie just beyond the edges of cities, or deep in valleys where tractors move slowly at dawn, and the smell of soil is strongest after rain. Imagine walking there as the morning mist lifts from the ground, and each blade of grass still holds a droplet of dew, refracting the first light of the sun. This is where one of our oldest relationships begins, a bond that links human life to the rhythms of the earth, not through machinery or measurement, but through seed and soil, warmth and water, time and trust. Agriculture is more than the growing of food. It is a negotiation with nature, a truce between the wild and the human, where land is reshaped just enough to produce what we need without undoing the balance that allows it to grow again. For 10,000 years, we have lived by this agreement. The Neolithic Revolution didn't just change our diets, it changed our homes, our societies, our sense of time. Crops require seasons. Seasons require calendars. Harvests require cooperation. And so the very idea of civilization was sown into the same ground that gave us barley, rice, maize, millet. But agriculture is delicate. It is utterly dependent on conditions, rainfall, temperature, soil quality, timing. A shift of a few degrees can delay flowering. A change in humidity can bring pests. A storm at the wrong moment can flatten an entire season's work. And the truth is, our entire civilization is still fed by a remarkably thin slice of the planet's surface, a narrow belt of arable land that relies on a stable climate. The domesticated crops we depend on, wheat, corn, soy, rice, are creatures of habit. They have been bred for predictability, a certain number of frost-free days, a certain balance of rain and sun, a certain altitude. They do not thrive in chaos. They cannot migrate like animals. They cannot adapt quickly. They are, in a sense, extensions of the climate itself, shaped over centuries to mirror the places they grow. And as the climate shifts, that mirror begins to crack. Already we are seeing crops pushed to their thermal limits. In some regions, heat waves strike during flowering, causing the plants to abort. Yields drop. In others, rainfall patterns grow erratic, either too little, turning soil to dust, or too much, drowning young roots. Saltwater intrusion, as seas rise and move inland, poisons rice paddies. Drought stress hardens the earth, making it less responsive to plowing and seed. Pests and diseases move poleward, thriving in new warmth, confusing farmers who once trusted the boundaries of ecology to remain in place. And the solutions, while technically possible, are not always simple. Irrigation, for instance, can compensate for drought, but it relies on water sources that are themselves vulnerable to change. Aquifers are being drawn down faster than they replenish. Rivers fed by glaciers are already shrinking as those glaciers retreat. Fertilizers boost yield, but at a cost. Nitrate runoff, dead zones in coastal waters, soil degradation over time. The very tools we use to stretch the limits of habitability often strain them further. It becomes clear then that agriculture is not just about growing food. It is about growing food sustainably in a system that can support both nature and need, and that is becoming harder. Some regions may benefit for a while as warming opens new growing seasons in higher latitudes, but others, especially those already vulnerable, may lose viability altogether. In the tropics, where heat and humidity are already high, even slight warming can tip fields into unproductivity. For millions of small scale farmers, these changes mean more than yield loss. They mean hunger, migration, collapse. Yet agriculture is also a place of astonishing resilience. Traditional knowledge, passed down through generations, holds techniques for dryland farming, for polycultures that resist disease, for water harvesting in arid zones. And modern science is expanding the genetic base of crops, creating strains that are more heat tolerant, more drought resistant, more efficient in their use of nutrients. There is a quiet revolution underway in seed banks, in agroecology, in regenerative farming. But all of it rests on a single truth. The climate must remain within certain bounds. No amount of innovation can save a crop if the rains do not come at all, or if the heat crosses thresholds never meant to be crossed. The thin thread that connects human life to the land is fraying not because the earth is uninhabitable, but because the conditions required to produce abundance are being tested. A habitable planet is not merely one where humans can breathe and drink. It is one where food can be grown with reliability, where soil can be enriched rather than exhausted, where seasons come close enough to expectation to build a future on. And food is more than sustenance. It is ritual. It is memory. The smell of bread in a kitchen. The planting of seeds in spring. The gathering of families around tables that reflect the harvest. These are not luxuries. They are anchors. When agriculture is disrupted, it is not just calories we lose. It is stability's culture continuity. When the land fails to provide, conflict often follows. Migration, tension, struggle. History is full of these moments. So as you lie in stillness, imagine a field just beginning to green. Imagine shoots breaking the surface, reaching for light they cannot name. Their fate, though fragile, is entwined with ours. We depend on that quiet striving, on roots holding the soil, on the arc of rain clouds above. Habitability is not an abstraction. It is the texture of life, the crunch of grain between teeth, the sweetness of a fruit at peak ripeness. The knowledge that something grew in the earth and found its way to your hand across thousands of invisible interactions. And somewhere tonight, that process continues. Even now, someone is harvesting under moonlight. Somewhere else, a seed lies beneath frost, waiting for spring. The earth still offers, But we must ask more carefully, more gently, because the future will be shaped not only by what we build, but by what we can still grow. Now drift outward again, not as before into the cold dark of silent space, but into a question that has tugged at our imagination for centuries. If this world should change beyond our comfort, if Earth were to shift beyond what we can inhabit, could we find another? Could we ever call another planet home? The question sounds futuristic, even romantic, but it is rooted in something deeply human: the desire for continuity, for safety, for somewhere to go if here is no longer enough. We have always looked upward for possibility. The stars have long been companions to our stories, our navigation, our wonder. In recent decades, telescopes and space probes have extended our reach, bringing the surfaces of other planets into view. We've seen the rusty deserts of Mars, the icy moons of Jupiter, the methane lakes of Titan. We've launched spacecraft beyond the solar system, sent rovers across cratered plains, listened for radio signals in the void, and most recently, with great anticipation, we've found thousands of exoplanets, known as worlds orbiting stars far beyond our own, each a potential cradle of life, each raising the quiet hope that habitability is not Earth's alone. Among these exoplanets, a handful lie in what we call the habitable zone, not too close to their star, not too far, in that narrow band where liquid water could exist. Some are Earth-sized, some orbit stars smaller and dimmer than our Sun, some may have atmospheres, some may not. But even when all conditions seem favorable, we are reminded that habitability is not just about distance or size. It is about complexity, gravity, atmosphere, magnetosphere, chemical composition. The presence of water, yes, but also the right kind of geology, the right kind of cycles, the right kind of time. Mars is the planet closest to our dreams. A cold, dusty world, etched with canyons and dry riverbeds. It once had liquid water. It may have once had life. Today it is a frontier, bare, dry, but not lifeless. We have sent robots to roam its surface. We have plans to send people. But Mars lacks a breathable atmosphere. It is exposed to radiation. Its temperatures plummet to deadly lows each night. Terraforming it, shaping it into something like Earth, would take centuries, perhaps longer, and even then, it might only be an echo of what we have here. The moon is closer, but even more hostile. No air, no protection, no water on the surface in any abundance. A place for bases, perhaps, for mining, for science, but not for home. Venus is shrouded in thick clouds of sulfuric acid. Its surface pressure is crushing. Its heat is unimaginable. It is the cautionary tale of climate gone too far. And so we look outward, to Europa, where oceans lie beneath ice, to Enceladus, where geysers spray from subsurface seas, to planets dozens, hundreds of light years away, where we know only hints, mass, orbit, temperature. We dream of traveling there, of finding a second Earth, of beginning again. But beginning again is not simple. Distance is vast. The nearest potentially habitable exoplanet is over 4 light years away. At current technology, it would take tens of thousands of years to reach it. Even with breakthroughs, it would require enormous energy, decades or centuries of planning, generations of travelers willing to leave behind everything they've ever known. And there is the deeper truth. We are not only shaped by biology, but by memory. We are made of earth. Our lungs evolved to breathe this atmosphere. Our bones formed under this gravity. Our sense of time, of beauty, of belonging, It all comes from here: the rhythm of ocean waves, the smell of rain on warm soil, the angle of the sun as it sinks behind familiar hills. These are not universal, they are local, deeply, specifically Earth. To live elsewhere would not only require survival, it would require redefinition. A new kind of sleep, a new kind of food, a new kind of childhood, shaped not by birdsong and breeze, but by machines and routines and the echo of a place never quite made for us. It could be done, it might be done, but it would not be the same, and perhaps, deep down, that is the real lesson. The search for other worlds is not futile. It is beautiful. It expands our vision. It reveals our context. It shows us that planets are not rare, that solar systems teem with variety. But it also shows us how astonishingly rare it is for everything to come together, as it has here on this pale blue dot. Habitability, as we've learned, is not just about conditions, it's about continuity, complexity, history, the intertwining of air, water, land, life, time. To find another Earth is not merely to find another planet in the right orbit. It is to find another system where all things hold each other in balance, where volcanoes breathe into the sky, and bacteria bloom in the sea, and forests filter the air, and clouds carry the promise of rain. And so perhaps, instead of looking outward as an escape, we might look inward as a return, not to the past, but to a deeper recognition of where we already are. The most habitable world we have found so far is the one beneath our feet, and it is still here, still spinning, still supporting. There is no harm in dreaming. The stars will always call, but the earth, this earth, remains the most perfect answer to that call, the only place where every cell of your body feels known, the only place where the wind sings in your language. Tonight, as you lie wrapped in air and gravity, resting in the soft pulse of a living world, know that the cosmos is vast and full of possibility, but home, at least for now, is still here. If you lie still enough tonight, you might hear a distant hum, not from wind or insects or the hush of trees, but from something woven into the world more recently: the murmur of machines, cooling fans, pumps beneath the floor, satellites blinking in orbit. The low electrical heartbeat of a world, wrapped not only in forest and ocean, but in wires and servers and circuits that have become as much a part of our environment as stone and rain once were. Technology, in its many forms, has become a second skin around our species, a kind of blanket we've stitched together, layer by layer, to hold the changing world at bay. It is tempting to believe that this blanket can become a permanent solution, a safeguard against a world that no longer behaves as we wish it to. And in many ways, technology already has expanded the bounds of habitability. It lets us live in deserts, on mountains, beneath the sea. It gives us light when there is none, warmth in winter, cooling in summer. We've built homes where no forests grow, grown food where no rivers run, carried voices across continents, and seen our planet from space. We've begun to simulate ecosystems in greenhouses, recycle air in space stations, model entire climates on blinking screens. And so, as Earth's climate becomes less predictable, less forgiving, we begin to ask, can we engineer our way through it? Can we replace what is failing with something artificial, deliberate, controlled? Can we, in short, build a backup Earth on top of the old one? Geoengineering is one such idea, a field both promising and controversial. It explores how large-scale technologies, might alter Earth's climate directly. Some proposals suggest injecting aerosols into the upper atmosphere to reflect sunlight, mimicking the cooling effect of volcanic eruptions. Others imagine brightening clouds over the ocean to bounce more heat away, or placing vast mirrors in orbit. These techniques aim to buy time, stabilizing temperatures while carbon emissions are reduced while ecosystems adapt. But these methods are not without risk. Climate is not a single dial, it is a web of interdependencies. Changing one thread can tighten or snap others. Regional climates might shift, rainfall might be disrupted, some areas might cool while others warm further. And once such a system begins, stopping it might cause rapid rebound warming. It becomes not a cure, but a commitment, one that requires generations of uninterrupted vigilance. Carbon capture is another tool, one with firmer grounding. We know how to remove carbon dioxide from the air, store it underground, or use it in materials. Some methods are mechanical, machines that scrub the sky. Others are biological, restoring forests, wetlands, soils. These approaches are slower, quieter, but they work with nature's systems instead of replacing them. They are not quick fixes, but long repairs. Then there is adaptation, technological responses that let us live with change. Floating buildings, desalination plants, vertical farms, artificial reefs, smart irrigation, early warning systems, drones that monitor crops, satellites that track wildfires. Each solution is a thread in the larger fabric, helping us respond to the world as it shifts. But even here, questions remain. Who has access? Who gets left behind? Can these solutions scale, or will they stay scattered patches on a blanket too thin to cover all? There is a deeper tension in these efforts. Technology gives us power, but also removes us. We grow distant from the systems we once depended on directly. We no longer watch the sky for signs of rain. We consult an app. We do not read the seasons in the land. We calculate yield through remote sensors. This distance brings convenience, precision, control, but it also erodes our intimacy with the earth. The more layers we place between ourselves and the planet, the easier it becomes to imagine we are separate, that we can manage it without understanding it, that we can fix it without loving it. And yet, this same technology allows us to see further, listen deeper, know more than ever before. Satellites show us the breadth of forests, the retreat of ice, the swelling of seas. Models forecast decades ahead, warning us where tipping points lie. Data speaks in patterns we would never see with our own eyes. And this knowledge is not cold. It can be a kind of reverence, a way of watching with care. Perhaps then, the goal is not to abandon technology nor to worship it, but to wield it wisely, humbly, as a partner to nature, not its master. To design not only for resilience, but for restoration, to build cities that give back, machines that mimic trees, energy systems that follow the rhythm of sun and wind. To use technology not to shield us from nature, but to reconnect us with it in deeper, more durable ways. The dream of technological salvation is powerful, but it must be rooted in something older. The understanding that no system functions alone, that even the most sophisticated machine draws from the Earth's veins, from metal, from minerals, from energy born in ancient sunlight, that even the cleanest innovation leaves a shadow unless we build with the future in mind. Tonight, as servers blink and satellites orbit and electric currents hum through walls and wires, let yourself wonder, What kind of world are we weaving with these tools? Are they extensions of our care or substitutes for it? Do they bring us closer to the planet's breath or further from its pulse? The warm blanket of technology can comfort, it can protect, but it must not replace the sky. There are places where the story of Earth's changing face is not theoretical, not deferred to the future, not captured in graphs or debated on screens. These are the edge places, regions where habitability is already shifting, sometimes imperceptibly, sometimes all at once. Along coastlines and deserts, across tundra and floodplains, people are living with the front lines of climate's long, slow turning. And in these places, stories emerge, not in headlines or numbers, but in footsteps, in decisions, in silences after loss. These are not stories of collapse, not yet. They are stories of adaptation, of resilience drawn not from abundance, but from the deep memory of how to live with change. Imagine a village in the Sundarbans, where the Delta River meets the sea in a tangle of mangroves and salt water. Here, the land is always in motion, eroding, flooding, reforming. The people build homes on raised mounds, reinforce them with bamboo. They watch the tides not just with science, but with inherited knowledge. But each year, the water creeps higher. Each year, the soil grows saltier. Rice no longer grows as it did. Fresh water must be fetched from further away. And slowly, families leave, some to the city, others to higher ground, unsure if they will return. What is left behind is more than a house. It is a geography of memory, a way of knowing the land that cannot be packed into a suitcase. Far to the north, in the Alaskan tundra, another kind of edge reveals itself. The permafrost, long considered stable, begins to thaw. Houses tilt as their foundations shift. Roads buckle. Ancient carbon, once locked in frozen ground, seeps into the air as methane. But it is not just infrastructure that feels the change. The caribou move differently now. The ice forms later. Subsistence hunting grows harder. For indigenous communities who have lived with the land for generations, this is not merely environmental change. It is cultural displacement, the slow erosion of a lifeway built on harmony with rhythms that no longer repeat. In the Sahel, the strip of Africa between the Sahara and the Savannah, the rains falter. Crops shrivel. Nomads travel further for pasture. Some conflicts that erupt are not simply political or religious. They are the friction of lives pressed against shrinking resources, of histories colliding in newly crowded landscapes. And yet, there too, people adapt. They dig deeper wells, revive forgotten drought-tolerant crops, share stories of years when the rains were kind, and hope they might be kind again. And in cities, the edges appear as heat maps. Neighborhoods with less tree cover grow hotter, suffer more. Elderly residents stay indoors, ration electricity. Air conditioning is a luxury in some homes, a necessity in others. Floodplains, once labeled once in a century, flood every decade now. The margins grow more visible between those who can buffer themselves from change and those who cannot. But edges are not just zones of fragility. They are also places of learning. In these spaces, solutions emerge that are rooted not in grand technologies, but in relationships. Community gardens in drought-prone cities, floating schools in flood-prone deltas, roofs painted white to reflect heat, fishermen shifting species as oceans warm, pastoralists trading roots to reduce pressure on grasslands. These responses may seem small, even improvised, but they are precise. They are born of listening. They are scaled to place. And from these stories, a deeper understanding unfolds that habitability is not only ecological, but emotional, that a livable planet is not just one where crops grow and temperatures stay mild, but one where people feel they belong, where the land carries their language, where the seasons echo their ancestors, where the stars rise in familiar positions. When those patterns fray, when the environment forgets the people who shaped it, something is lost that cannot be measured in degrees. Yet, even in that loss, there is dignity, there is creativity, there is the quiet courage of staying, of rebuilding, of refusing to turn away from the land that has always held you, even when it begins to change. There is also the quiet courage of leaving, of carrying songs and seeds to a new place, of making something unfamiliar into home. Both paths require strength. Both are part of the human story. We often speak of climate refugees as if the term only belongs to people crossing borders. But migration can be internal, emotional, generational. A shift in weather that makes a young person move to a city. A grandmother who watches her childhood fields dry up. A child born in a neighborhood where the air is too hot to play. These are displacements, too, small departures from what once was safe. And yet, the earth still offers. New places become green. Forgotten knowledge returns. Some species adapt. Some communities grow closer in shared effort. The earth, while changing, is not done welcoming. But its welcome is different now. It is not the same for all. And so we must learn from those at the edges, not only their techniques, but their perspective, of their willingness to listen to a place and respond with care instead of conquest. Tonight, someone is repairing a wall washed out by flood. Someone else is harvesting a new kind of grain that can survive drought. Someone is writing down a story told by their grandfather about the last time the river moved. Someone is testing seawater to see how far the salt has crept. These are not grand gestures. They are quiet acts of survival, of honoring the ground even as it shifts. And as you lie in stillness, wrapped in the safety of your own place, remember that the world is not a circle with a single center. It is a tapestry, fraying in some corners, healing in others, constantly rewoven by the hands of those who dwell closest to change. Beneath the soil, deep in polar ice, and layered in the quiet bottom of lakes and oceans, Earth keeps its memory. It does not record history in ink or images, not in language or symbol. It remembers in layers, in isotopes, in rings of wood, and shells of ancient sea creatures. It remembers through trapped bubbles of air in glaciers, through the slow accumulation of sediment in forgotten basins. To read the planet's past is to listen to these silent witnesses, to understand that the Earth is always keeping time, even when we are not. In the icy heart of Antarctica, scientists drill deep into glaciers, pulling up long cylinders of compacted snow that became ice over thousands, even hundreds of thousands of years. In these ice cores, tiny air bubbles tell us the composition of the atmosphere long ago, how much carbon dioxide was present, how much methane, how warm or cold the Earth was. Each layer is a year, like tree rings in frozen form. Through them, we learn of past climates, of ancient droughts, of great shifts in the Earth's breath. We see the rising and falling of temperatures, the natural rhythms of glacial and interglacial cycles, and more recently, the steep climb of industrial-era greenhouse gases, an abrupt spike against a long, slow backdrop. Tree rings tell another story. In old growth forests, trunks thicken each year, and the width of those rings captures rainfall, temperature, stress. A narrow ring might mean a drought. A scar might speak of fire. Together, they create a timeline of regional climate, centuries long in some cases, etched into the wood in a language older than words. In the ocean depths, sediments settle like dust in a still room. Tiny shells from plankton drift down after death, creating fine layers that can be analyzed for clues. Their chemistry reveals the temperature of the water they lived in. Their presence, or absence, tells of ecosystem shifts. Volcanic ash layers, pollen grains, chemical signatures of industrial metals, they all collect, undisturbed, forming the strata of the Earth's diary. And then there are fossils, fragments of creatures that once walked or swam or bloomed. Some are familiar in shape, the curl of a fern, the tooth of a great fish, the imprint of a feather. Others are cryptic, speaking of lineages that vanished before we ever knew them. Fossils are more than curiosity. They mark transitions, when climates changed, when continents moved, when extinctions came suddenly or slowly. They show us not only what Earth once held, but how it responded when things changed. Taken together, these records tell us something both sobering and reassuring. The Earth is not new to change. It has shifted climates before. It has endured great warmings, deep freezes, mass extinctions. And each time, life continued, sometimes flourishing, sometimes faltering, always adapting. Earth forgets nothing. It carries the traces of every era in its bones. But what of our memory? We humans are good at stories. We carry the past in songs, in oral traditions, in books, in ruins. We name years after disasters, after revolutions, after kings. But our memory can be short. We build in flood zones, forgetting the last flood. We plant in dry lands, trusting rains that no longer come. We settle on coasts that are already retreating. Part of this is hope. Part is necessity. Part is that we are not always taught to read the signs the earth provides. And yet, there are those who remember. Indigenous communities who hold stories of great migrations, of vanished rivers, of fire as a tool and teacher. Farmers who recall the exact day the rains used to arrive. Fishers who know when the sea turned strange. This memory, passed between generations, is a form of resilience. It may not always be written, but it is felt. And now, as Earth warms and shifts, we are being asked to remember in new ways, to carry the lessons of ice cores and satellites alongside those of ancestors and soil. We are also, in our own way, leaving records. Our cities, our emissions, our plastics, our changed rivers, these too will be legacies. A future geologist, thousands of years from now, might find a layer rich in aluminum, concrete, and chicken bones. A sudden warming spike in ancient ice. The fingerprint of a species that altered the course of planetary systems. We are writing our chapter in Earth's memory right now. It will not be erased. The only question is what story it will tell. Some envision a future where Earth's habitability declines sharply, where ecosystems collapse, and human life becomes fragmented, clinging to technological enclaves. Others imagine a slow adaptation, a reweaving of societies into closer harmony with natural cycles. Perhaps both paths will exist in parallel. Perhaps the story will not be one of triumph or failure, but of complexity, of learning, forgetting, learning again. Even now, we are shaping memory. Each act of preservation, a forest spared, a wetland restored, a species protected, is a choice to continue a story that might otherwise be cut short. Each innovation in clean energy, each effort to reduce waste, each decision to listen more carefully to the land is a line written toward continuity. And each night we sleep beneath the same sky our ancestors once saw. We become part of that memory. Even if the stars are dimmed by city lights, even if the seasons shift, the earth remembers the rhythm of our breath, just as it remembered the breath of the great mammals, the trilobites, the ancient trees. Tonight, you rest in that long chain of remembrance. Your breath joins the atmosphere. Your warmth adds to the tally. You are not separate from the record. You are a living line within it. Let the world fall quiet now. Let the edges blur and the light dim until what remains is a hush, soft, planetary, deeper than wind. You've traveled far through time and space, through layers of earth and echoes of memory, and now the journey leads not forward, not outwards, but downward and inward into the slowest of rhythms, the sleep of continents, the long breath of stone, the final chapters written not in catastrophe, but in stillness. The continents shift even now, drifting at the speed of fingernails, colliding and separating in cycles that span hundreds of millions of years. Once, all the land was joined as Pangaea, a single massive supercontinent. It split slowly into pieces that moved away from one another, becoming the continents we now know, shaped by oceans, divided by mountains, drawn by the restless forces of heat beneath. And in time, they will come together again. A new Pangaea will form, not in our lifetime, not in 1,000 lifetimes, but inevitably. The earth moves not with purpose, but with pattern. That pattern continues even as its pace slows. The core cools. The mantle flows more sluggishly. Tectonics, once vigorous, will begin to fade. Volcanism will quiet. Earth's magnetic field, born of the swirling iron within, may weaken or vanish. Without it, the planet's shield against solar wind thins. The atmosphere, once held so tightly, begins to leak away, molecule by molecule, drifting into space over eons. And the sun, ever faithful, grows brighter still. One day, not through violence but through inevitability, its warmth will become too much. The oceans will evaporate, leaving salt pans and cracked basins. The air will grow thick with vapor, then thin as water vanishes, and carbon dioxide breaks down. The biosphere, once teeming and layered with sound, will retreat to its simplest forms, then fade, not with an explosion, not with a scream, but with a sigh. This is not a tragedy. It is the completion of a cycle. Stars are born, burn, and die. Planets form, bloom, and change. Life arises, flourishes, and transforms. What matters is not the permanence of any one era, but the grace with which one stage flows into the next. Earth has already lived through 5 mass extinctions. It has seen ice cover the equator, and forests grow at the poles. It has carried fire and flood, silence and song. It has held trilobites and whales, lichens and languages. And through it all, it turned. Now imagine the far future, not the Earth of now, but the Earth of then. A quiet planet with no oceans, no green, but still turning under a soft, bright sun. The continents are joined again. Mountains have worn down. There is no more plate tectonics, no breath, no cities, no clouds. But still, the rock remembers. Still, the orbit continues. Still, the rhythm remains. Perhaps by then, life has long since moved elsewhere. Perhaps not. Perhaps some form of life clings still, deep beneath the surface, or far beyond it, seated by those who once called this planet home. Perhaps memory itself has become something that moves between stars, carried not in flesh or paper, but in patterns and pulses, in whispers of data, in vessels drifting across centuries. Perhaps someone or something still remembers Earth, not the name, perhaps, but the feeling, the story, the blue and green, the clouds, the moon, the sleep. Because Earth was not just a place, it was a possibility, a balance so fine, so fleeting, and so beautiful that it gave rise to everything we know. And that is how it ends, not with answers, but with quiet. Because this was never a story about endings, it was a story about breath, about the way life rises and falls like waves, about how the air holds us, about the fragile perfection of now. You are here tonight in a body made of stardust and rain, lying on a planet that spins gently through an ocean of light. The world has not ended. It endures, and it holds you still, with all its flaws, all its changes, all its grace. Tomorrow will come, perhaps warmer, perhaps quieter, perhaps filled with challenge. But tonight the air is still good, the ground holds steady. The trees, if they are near, breathe with you, and so we rest. In the slow rhythm of a planet not yet finished, in the long dream of Earth.